Okay, so we've got a question here. We need to find the greatest integer k when 823 factorial divided by 7 to the power of k is in a set of integers. So how are we going to go about calculating what k is? We know that we've got to get a fraction, but how can we find out that it's going to be a whole number and the largest value of k? That's the object of this question. So one lucky thing is we've got factorial in the numerator. Now 823 factorial, that's a very large number. 823 factorial has 2044 digits. Now if you follow the link below, I'm going to show you how to calculate how many digits there is and how many trading zeros this has. So there's going to be so many zeros at the end of that as well. So I'll follow the link and I'll show you that. So back onto this question, 823 factorial divided by 7 to the power of k. We also see that 7 is a prime number. That's also really helpful. So we can use a particular formula. So we've got n factorial divided by a prime number to the power of k. To find k, what we do is we have k equals sum from x equals 1 to infinity, and we use something called, we can use the floor function or we can use the greatest integer function. This time I'm going to use the greatest integer function. It's going to give us the same result, but it's just different notation. So greatest integer function is basically 2 square brackets like that and then a number inside, and then we're going to have n divided by p to the x. So you can see what's going to happen here. We're just going to sum them all up over p to the x's. Okay, so here we've got 823 factorial. I'm going to write that down again here, divided by 7 to the power of k. So we want k. So k equals x equals 1 to infinity, greatest integer function, and 823 is our n, and our p is 7, and that's to the power of x. And just to confirm this greatest integer function, if we have greatest integer 5, that equals 5. The greatest integer 3.8, that equals 3. And then the greatest integer minus 4.7, oh, try that a little bit better, 4.7, that equals minus 5, because we're moving down from minus 4.7, we're moving to the lower number. Okay, back onto this. 823 divided by 7 to the x and the greatest integer of that. So with the summation formula, it's just simple. We just plug in all the different values of x and see where that takes us. So for the first one, so for x equals 1, we've got 823 divided by 7 to the power of 1. Take the greatest integer of that. Well, how many 7s are there in 823? Well, 7s into 840, there will be 120. So we got 117. So that would be our floor function, our greatest integer value here. We could also use the floor function, like I just mentioned. So same with these. The floor function of 5 equals 5. The floor function of 3.8 equals 3. And the floor function of minus 4.7, that equals minus 5.2. So that's the first one. Now we move on to x equals 2. So greatest integer function, 823 divided by 7 squared. Now 7 squared is 49. So 49s into 823. Well, we got 1 with 33 left over. 49s into 333. That's going to be 16 altogether, isn't it? 16 times 49. Let's just work that out. 49 times 16, 490, 65, 300, 294. That gives us 784. So yeah, that's perfect for us. So that's 16. Now on to the next one. 823, 7 cubed. So 7 cubed is 49 times 7, which is 343. So 823 divided by 343, that's going to give us 2 in terms of our greatest integer function. And then our last, and I'll explain why that is in a minute, 823 divided by 7 to the power of 4. 7 to the power of 4 is 2401. Let's just write that here. That equals 7 times 7 times 7 times 7, 2401. 823 divided by 2401, that's going to give us 0 in terms of our greatest integer function. So we won't need to go past 4 because there will all still be 0 as well. Even if we go to 5, 6, 7, 8, they'll all be 0. So that just leaves us now with this sum. So we've got 117 plus 16 plus 2, that gives us 135. So therefore we can say that our k is 135. So what we can say is that 823 factorial divided by 7 to the power of 135, this will give us an integer. And if you want to know what 7 to the power of 135 is, I'll do a video on that, and also if you know already, you can write it in the comments below and we can have a look there. Okay.